Hello, it's Scott Manley here, and today I would like to give you all a tutorial on how to build aircraft capable of vertical takeoff and landing. Now, there is a stock VTOL that comes with the game, which it basically uses rockets. I'm actually going to concern myself with a proper aircraft which can fly using regular aerodynamic surfaces and then transition either to or from vertical flight and land on jet engines. So we're going to start out with the Mark II cockpit. Because the Mark II cockpit is the new hotness, it has been introduced to the game. Now, the important thing that you're going to be looking at is your center of mass and your center of lift. Now, center of mass is actually going to be the most important thing. You want an aircraft which, as it burns fuel, the center of mass does not move. So what I'm going to do is grab this Mark II liquid fuel fuselage. And you can see inside it has 600 units of liquid fuel, and as it burns you can see the center of mass moves forward. Okay, that's not complete just yet. You're going to have to balance this out and put an engine on the back and everything else, right? So, for example, turbojet engine. Well, we can stick that on there. What does that do? Well, the center of mass still moves. You see, if I have an engine sitting underneath and firing straight upwards, as this fuel burns down, it will find itself getting pushed in the wrong direction, right? Now, you can do this in a number of ways. You can balance it by adding parts, and some obvious parts would be things like the Mark II adapter. Now, the Mark II adapter comes, or the Mark I to Mark II adapter comes with fuel inside it. You probably don't want this in here at all, because as it burns down, it will draw from the fuel tanks in a different order. Okay, so how does this work? That's pretty good. Moves backwards just a little. Maybe what I'm going to do, and here's another useful trick, is I'm going to add in the drone cores, right? Now the drone cores, while we have a command pod here, the drone cores are going to add some extra torque, and that means that if the center of mass moves, and it does still move a little, then your aircraft will still have enough torque to counteract the natural rotation of that is due to the engine around the center of mass. Okay. So, next thing you want to do is add engines. And I have done a design which has fuel in the middle, so I'm going to have engines on either side. You could, in theory, put an engine under here, right? We're going to use these little basic jet engines because they're going to work better at low speed and low altitudes than the turbojets. But of course, they don't attach normally. You need to use structural parts to attach them, and there's a bunch of different ways to do it. You can use cubic octagonal struts, you can use structural panels, you can use I-beams. These things all have radial attachment possibilities, and then they have a node that can be attached as well. There is the radial attachment port, which I quite like because it looks the part. So actually let me show you how I do it with radial attachment ports. Oh yeah, some of these parts you have to be very careful because when you attach them they can disappear inside a wing. Oh yeah, a wing! Well, since we're going to be making this an aircraft which actually flies, we're going to need wings. Now, normally you would attach these wings down the middle, right, because you would be building around your kind of center of mass and center of drag. But if you do that, you may not have the ground clearance you want, so I kind of think it's better to put them nearer the top and then adjust the rotation until they're horizontal. Put this forwards I'm going to put it right there actually. So yeah, that's pretty good. Center of lift and the center of mass are still balanced, that's good. Now you want to put on these things in pairs. I'm going to just try and aim to figure out where this is. Now, there's a cunning trick you can pull here, right? What I'm going to do, there we go, is I'm going to put these on in this orientation, right? Now, turns out you can actually access the attachment node just fine. Although you have some symmetry, it complains about clipping in the symmetry part. So you can either turn on no clipping or just attach them individually. And you will work just fine. So these engines will also need air intake, so let's attach these while we still have a chance. Put a couple of these on the side. We're not going to need huge amounts of air intakes. Okay, so now we've got that, we now need to build out the actual aerodynamic components. These things, I think these things will actually drain fuel through the wings through this. If not, we'll have to come back and add fuel lines, but I think we'll be fine. So I'm going to add some wing parts, and we want to keep, normally you would want to have the center of lift behind the center of mass for forward flight stability. If you're flying a VTOL, you have the possibility to fly in reverse flight, and so you don't want to have it too far back. There we go, let's add this. So rotate these, and you have to also accept that when you add control surfaces, you're going to adjust your center of lift. So don't worry too much if your center of lift is too far forwards initially, because you'll probably be adjusting it backwards just a bit. Okay, well, that doesn't look like the craziest design I've ever seen. And center of lift is still a little forwards, but I think we can do just fine. Let's put these on. And let's put... actually, yeah, let's use the big flaps and go smaller as we go in. Yeah, let's really look the part, huh? Okay, these... followed by these, which have some bizarre different rotation techniques. Ah, there. That's starting to look a whole lot more stylish, and you'll notice my center of lift has gone backwards. For the tailplane, I like these little winglets here. We're just gonna rotate them. No, that's not it. That's it. Do it this way. Yeah, rotate these. So these will provide some lift to help us get off the runway. Make sure to assign your groups here. I'm just going to use this for pitching. These ones can apply for everything except yaw. And we will need a tailplane. Delta Deluxe winglets are pretty good for this. Just stick a couple on there. And you don't need to put them too far back, because again, remember, you're going to have to deal with reverse flight, but it will help if you can make it somewhat stable in that direction. The further back this is, again, you will be more stable, but you will be less likely to flip out of control once you start reversing by accident, because planes tend to do that. Okay, I think we've got almost everything here. Oh, of course, we need landing gear. Landing gear, you can go with whatever pattern suits you. I like 3-point landing gear, but some of you may want to go with straight up 4-point landing gear, because you are trying to have something that is able to take off vertically. Again, remember the rules about fulcrums and try to make sure that you're able to rotate on the runway and not have to worry about going out of control. So there, yeah, that's looking pretty good. We've got some force back here. Maybe might move these forward just a touch. There, okay. Well, assuming that the fuel flows correctly, this will be all set up for me. Now we just need to assign action groups. I like to attach toggle engine to group 1, and group 2 is vertical engines. Toggle engines, and let's call this test. VTOL. Okay, so we're on the runway. First thing is, I'm going to set up enable my brakes, enable SAS, throttle down to 0, and then activate those vertical engines. And it does say that we have liquid fuel available to us. So with 2 engines in an aircraft of this mass, about 1/3 thrust will be enough to start lifting me up vertically. So I just want to do a little hop, and then we'll land, and then we'll see if we can actually fly horizontally. Just a little more here. Okay. Oh, come on. Oh, almost. Oh, yes, look. Now we're flying. Now we'll throttle back down. And we'll touch back down on the runway. And touch down. Cut the engines. Now switch from engine group 2 to engine group 1. We'll try horizontal takeoff. Throttle up to 100%. We should have a lot of wing surface on this thing, so it should actually lift off relatively easily, assuming it can torque around the gears here. One engine is enough to give it some serious drive, but yep, having a bit of problem with gear placement there. Those rear gears should perhaps be placed forward a little, but nevertheless I get up. And once I'm up, it does actually turn relatively well there. So this is a functioning vertical takeoff, horizontal takeoff. I'm presuming we can land it. Now what I want to test is a transition to transition from horizontal to vertical flight. Now, if you've seen Harriers and the design of them, they have like thrust vectoring. They have a single engine, or they might have multiple engines. The point is they have like thrust vectoring nozzles where they can adjust these things forward and backwards. Kerbal Space Program doesn't really have that, so instead of thrust vectoring you need to use multiple engines. Okay, so I'm firing up these vertical engines. I'm going to throttle back and throttle down, pull myself into a steep vertical climb. The idea is by climbing and turning I want to kill my velocity, and I've done such a thing. So now pick up 30% or thereabouts, and I'm more or less hovering. Well, not really I'm travelling much more slowly than the wings would let me. So let's actually try aiming for the vehicle assembly building. This is actually horrifically difficult, but I'm going to put the gear down optimistically. Okay, yeah, travelling at about 10 meters per second. Now, if you want, you can also attach a docking port on top, and that helps a great deal because you can then do control from here, and that means that you will control it more like a rocket landing vertically. Flying on jet engines, is a lot harder than flying on rockets because jet engines have spool up and spool down times. So the control lag can make it really difficult to accurately maneuver your vehicle. On the other hand, they sip fuel so gracefully you have a lot of time to learn to fly them. Okay, throttle up. And this is where I'm probably going to crash because I've not been paying too much attention to my positioning. Oh, letting the nose drop a little. And, yes, doing pretty good so far. Doing pretty good so far. Just slow down, slow down, slow down. Oh, there. Brake, 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 brake. No, 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 no. Oh, yes. Well, not entirely unsuccessful flight. But I have to be careful not to fat finger those controls again. Let's take a look at some other design concepts. Okay, so if you don't want to have those two ugly external engines, or perhaps if you just want a single lifting engine, then the new version of Kerbal Space Program offers the ability to put a single engine in line and inside one of these bays. So here's just a rough example of what you would do. Obviously there's no fuel in this system here. No, actually, obviously there's no fuel in this system because if I had fuel in that rear compartment it would not balance. So you can put an engine in there, and the best way to do it is using the cubic octagonal strut. Let's lift this up a little so we can see where it goes. So it'll attach to the middle there, and you can't really see where it is, but you have to actually press the W key a couple of times to invert it. And that actually looks like it's mostly... I'll actually move it that way just a bit. There we go. I think that's just fine. Let's remove this out of the way. Nope, it's in completely the wrong place. I completely messed that up. There we go. That's much easier when you don't have the indicator telling you where you need to put the thing. So yeah, if you don't rotate it around, it will be sticking out the other side of the aircraft. Anyway, you can drop your basic jet engine in there and it will draw fuel from the aircraft around it. Which leads me to where do you put the fuel? Well, the obvious way to do it is all your fuel has to be balanced around this unit, right? You have to have equal amounts of fuel on either side because you're going to drain the fuel and you need to keep your aircraft balanced. So you can use the Mark II liquid fuel storage tank there, and you can drop another one on behind it, and that's you got a balanced core here, which will work. The problem is that this one will drain first, followed by this one, so you're going to have to manually do the Alt, right click and fuel transfer, continuously to keep this thing stabilized. I mean, having these probe cores here helps a whole lot, but as you hover, you'll watch and you'll see that your pitch correction will start to shift slowly over time. The other way to do it is you just put this back in here. You can obviously have stability, or you can have your fuel balanced across the lateral axis, say using the Mark I fuselage, and that contains jet fuel as well. They are 150 units of jet fuel. Gonna need to transfer the fuel inwards to make sure that it gets in there. And then, yeah, you can have, you know, your cool air intakes, make your aircraft look as funky as you like, have some, you know, aerodynamic nose cone on the back or something like that. And then, of course, you're looking at wings and things and other stuff. That should work pretty well, and you can build that into a pretty functional aircraft. Okay, so here is what I've built. I've added wings, I've added control surfaces, wheels, reaction control system, and of course we have this smooth underbelly that will conceal the position of our beautiful lift engine here. Now, it's kind of hard learning to rotate this thing and not crashing the engine into the ground, but now we're off the ground, great. We can actually fly it like a real plane, and it flies pretty well actually. Just gonna zip it around for a bit. Oh, losing altitude there. We don't want to get too low. Then again, we don't want to get too high, because getting too high means we have a long way to go to land it. Okay, so let's try transitioning to horizontal flight. Yes, let's try transitioning to horizontal flight there. We all saw that almost come. Rather, let's try transitioning to flight on the vertical engine there. Okay, so open the doors. There we go, we have the engine showing, and fire that engine up. Disable my horizontal engine, and I guess we're just going to fly around over here and try a landing. So to bleed off speed, I turn in a circle with this engine firing. That should help me a bit. And then throttle back to something that lets us move more or less at, without gaining too much altitude. I guess I can try and aim for the runway. Now, you're going to find that if you try to hold position, then as you're manipulating the controls, you will inevitably pick up forward velocity, and that is simply the infiniglider effect, right? All the control surfaces are generating phantom forces because, well, let's face it, the aerodynamics in Kerbal Space Program do need a lot of fixes. So you might find yourself having to keep the nose high just to maintain horizontal or to maintain position. I've also got a reaction control system on this, and you can see it firing. This is obviously using monopropellant. Real aircraft that do this, they actually have, many of them, have airjet systems which are fed off of the main engine, and that lets them translate a little better with a little more fine control. I can use the translation controls here to give me a little faster response than the engine to avoid this spool up and spool down effect. But they're brilliant right on the runway. That was a pretty good landing, I think. Obviously, if you want to carry monopropellant on this, then you need to put them in a stable position. We have the advantage, of course, with monopropellant that all of the tanks drain equally. But yeah, you know, these things are quite fun to learn to fly. Okay, so just to show that it is actually possible to land these things with pinpoint precision, with a bit of luck. I mean, yeah, it is possible to fly these things. They are not the easiest to fly, and I will be the first to admit that I'm rubbish at flying the aircraft. But I've learned a bit over my time, but all the same, this is not particularly easy. So just because you have a good design doesn't mean you're going to be able to fly it. But there I go, and I fat finger the controls, but I do manage to put it on top of the administration building. So it is possible, and this is pretty much the design that I built earlier on, the first design that I built. So the important thing to remember really is build out the core of your aircraft first, figure out where the fuel will come from, then put in your vertical lift engines, and then build the wings and make sure the wings have a center of lift which is practically on the center of mass, and you will be golden. Oh yeah, and also make sure your landing gear is set up appropriately. And it always helps to have things like probe cores and reaction wheels to provide extra torque, just for when things are trying to push you in the wrong direction. So go out, give it a try, see what you can build. I'm Scott Manley, fly safe.